First question says factorize 2y squared plus 5y plus 3. So we have a quadratic equation and they want us to factorize it. So the first step is to multiply the coefficient of y squared with the constant. So 2 times 3 is 6. Next step is to find factors of 6. Now factors of 6 apart from 2 and 3 are 6 and 1. So now we have to pick that set of factors which when added or subtracted give us the middle term, which is 5. So we know 2 plus 3 is 5 and 6 minus 1 is also 5. Both of them are giving us 5, but which set of factors will we choose? But which set of factors will we choose for this equation? If I start with 6 and 1, we have 2y squared plus 6y minus y plus 3. So if we compare the initial equation with the equation I've made, what I've done is that I've just replaced 5y with 6y minus y. Because 6y minus y will also give us 5y. So we're just replacing it with the factors of 6, where the initial equation still doesn't change. Because if we just combine it, it's back to that one. But the reason why we're doing this is because we want to factor this by grouping. Because right now, if you look at the initial equation, we can't factorize it because there's no highest common factor or any other way we can do it. So the only way we can factorize this quadratic equation is by replacing it with the factors of the product of the coefficient of x, the y square, and the constant, and then using those factors to replace the middle term. So now we're going to factor this by grouping. And by that, what I mean is that we're going to split the first two terms in one group and the last two terms in another group. So between the first two terms, we have 2y common. So that gives us y plus 3 in the bracket. And between the last two terms, we have negative 1 common. That gives us y minus 3. Now, if you notice, we can't further factorize it because the terms inside the bracket, they're not the same. Well, the numbers are same and the terms, but the signs are not same. Here we have positive 3 and here we have negative 3. So since they're not both positive or both negative, we can't further factorize it, which means 6 and 1 were not the ideal choice for this equation. So now if we rewrite this equation, but with different factors, which is plus 2y and plus 3y, which also add up to 5y, we'll see if we can factorize this. So the method is still the same. We're going to factor by grouping. In the first two terms, we have 2y common. So 2y outside and y plus 1 inside the bracket. And between the last two terms, we have 3 common. So y plus 1 inside. Now, if you notice, y plus 1 is the same for both 2y and 3, which means we can take that common and we're left with 2y plus 3 in the second bracket. And this is your fully factorized answer for this quadratic equation. We can't further factorize it. It's in the form of its factors. And that is your answer. Next one says, find the equation of the straight line passing through the point 0, 6, which is perpendicular to the line y equals to 3x plus 1. So before we begin with this question, you need to first remember the properties of perpendicular lines. If two lines are said to be perpendicular, let's say this is line 1, this is line 2, and they're perpendicular, then the product of their gradients would equal to negative 1. M1 being the gradient of L1 and M2 being the gradient of L2. And when you multiply those gradients, you get an answer of negative 1. This is a fixed rule. So if this line has a gradient of, let's say, this is M1, which is 3, because this is in slope-intercept form. So the coefficient of x is your gradient. So M2 would be 3 times M2 equals to negative 1. And that's negative 1 over 3. So if we compare that with the gradient of L1, we can see that what we need to do is take the reciprocal of the given gradient and change the sign. So 3 becomes 1 over 3, but negative as well. And in the question, they've already given us the y-intercept, which is 0, 6. Why is this the y-intercept? Because our x value is 0. So if we look at the slope-intercept form, y equals to mx plus c is 6, and m is negative 1 over 3. So y equals to negative 1 over 3 x plus 6 is our equation of the line that is perpendicular to y equals to 3x plus 1. Next question says, we have 4 different graphs and they want us to match the graph with the equations. They've already done the first one, y equals to x squared, which is a quadratic graph, is graph A. Graph B is your exponential graph. So that means it's going to be y equals to 2 to the power of x. Graph C is your rational or inverse graph. Both terms are correct for this. So that is your y equals to 1 over x. And lastly, graph T is your cubic graph, which is y equals to x cubed. These questions are very scoring if you remember like which equation has like what graph. There's no calculation involved, you just need to match the graph with the equation. That's it. Next one says, percent primes are prime numbers that can be written in the form of 2 to the power of n minus 1, where n is a whole number. It says if n equals to 5, is 2 to the power of 5 minus 1 a percent prime number? So let's check. 2 to the power of 5 basically equals to 32. So 32 minus 1 equals to 31, and 31 is a prime number, so yes. Then it says if n equals to 8, is 2 to the power of 8 minus 1 a percent prime? Similarly, we find the value of 2 to the power of 8, which is 256. So 256 minus 1 is 255. Now we know if any number ends with 5, it comes in the 5 times table. We can easily see that this number has more factors. It's not just 1 and the number itself. So which means this is not a prime number. Because for a number to be a prime number, it needs to be divisible by 1 and itself. That's it. It cannot have any of the factors. So this is your answer.